we present Hamba, a novel method for single-view 3D hand reconstruction with graph guided by scanning Mamba. 3D hand reconstruction aims to reconstruct the pose and shape of hands from a single RGB image, without camera parameters or human body context. Present transformer-based models fail to reconstruct a robust mesh, particularly for in the wild scenarios, which include occlusions, truncation, and hand-object interactions. Relying solely on the attention mechanism for direct hand mesh reconstruction does not fully exploit the joint spatial sequences. To address this issue, we aim to leverage graph learning and state space modeling to learn the joint spatial sequences and relations. For this, we propose a graph-guided state space (GSS) block that reformulates Mamba's unidirectional scanning as a graph-guided bidirectional scan, thus adapting it for 3D reconstruction using a few efficient tokens. The transformer's traditional attention operation requires calculating correlation among all tokens, which leads to ignoring the relations between different joints. In contrast, our graph-guided bidirectional scan captures the relation between fingers using a few tokens. A naive direct application of Mamba for 3D hand reconstruction results in an inaccurate mesh, due to the unidirectional scanning and the lack of a specific design for 3D reconstruction tasks. Since graph learning has the capability to capture node relations effectively, we integrate graph convolutions into state space modeling. This significantly enhances the feature representations by considering the intricate hand-joint relations. The Hamba model is relatively simple to understand. First, we feed the cropped hand image through a backbone to extract token, which goes through a downsampling process. Next, the tokens are input into a joints regressor, which predicts the 2D hand joints, which is utilized by the token sampler as a strong local context. These tokens are fed to the graph-guided state space block and concatenated with the mean token, which provides the state space model with a strong graph structural relationship, apart from the local and the global context. Finally, we fuse all tokens together and regress the mono-hand parameters. Here we present a visual comparison of Hamba's hand reconstruction with state-of-the-art models in the wild images from real cooking videos. This includes both non-parametric models like Metro and Mesh Graphomer, which directly regress the vertices, and parametric methods like Frank Mocap and Hammer, which regress the mono parameters. This scenario is particularly challenging since it has high occlusion, hand-hand and hand-object interactions, along with truncation scenarios. Extensive experiments on multiple benchmarks demonstrate that Hamba significantly outperforms state-of-the-art methods, and also achieves rank 1 into challenging competitions leaderboards on hand reconstruction. We additionally present an ablation study to verify the effect of proposed components, both qualitatively and quantitatively. Here, we see that the major performance drops are caused when the proposed graph guided by directional scan and the Mamba blocks are removed. Here, we additionally present Hamba's results on multiple challenging videos. Example, a person playing keyboards, which is challenging due as the model needs to reconstruct the fingertips robustly. Next, we present results of a person playing the guitar. Here the challenge is capturing the fast motion of her hand. Here we reconstruct hands of a person playing the piano from side view. We also include reconstruction results of person performing origami arts, which is very challenging due to the intricate finger movements. Next, we present results of finger gestures, wherein the persons has finger-finger interactions. Lastly, we present two more cases of hand gestures and a girl playing a lute. On all challenging scenarios, Hamba consistently reconstructs the hand mesh.